So that is the program of presentations and such. And so now, and we were scheduled to end at my time, 5 o'clock, and it's now 10 minutes to 5. But so we have 10 minutes for our final panel. So I assume I would suggest that we, since we've been, that we shouldn't try to reclaim all of our time in this last panel. So we should have a little bit longer than 10 minutes, because I think this is where we could have a good, interesting discussion. So I guess what I propose is that we plan to go for half an hour or something like that. Is that okay, Annie? And if people have to leave, they have to leave. I apologize for the schedule slipping. So anyway, I also would like to have this open up a little bit. I don't want it to be as closed. Since we've had to cut things short, we haven't really had enough time to discuss all of the papers at the levels people would like to. So I think I would like to also allow people to, if they have questions for other people on the panel, off the panel, anybody who's here, feel free to ask such a question. And so everybody should be aware that you might be asked a question, even if you're not on the panel. Okay, so, but to get it going, I will share my whole screen so you will see everything and everything. So let me bring up the questions that I had originally thought of asking. And so can you see my questions?
Yes.
Okay, thank you. Okay, so these are the questions that I'm sorry, I should I guess start with introducing the people who are supposed to be on this panel, who are on this panel. Like I say, I want to have it be open. So Ed Thunberg, Bob Kowalski, Guido van Rossum, Peter Norvig, Gopal Gupta, and Nengfa Zhao. Is Nengfa on today? I don't think I saw him.
Yeah,
oh,
I'm here, David.
There you are, Nengfa. I'm sorry, you were hidden in the 50. Glad to see you. So good. So you also can be.
And I'm going to take 10 seconds to let my dog out. I'll be right back.
Please do. Thank you. You might have noticed I disappeared for a short while at the end of Michael. I apologize. I realized I needed a bio break, and if I was going to go another half an hour, I was going to not make it. So I apologize. Please, anybody who feels the need, by all means. Okay, so those are the panelists that we had sort of planned this around, and so I just put up a bunch of questions, proposed them to the panelists as questions we might want to think about. I have no super commitment to these, but if we don't have, some of these I thought were sort of interesting. I'd like to hear people's opinions. And as a matter of fact, we have gotten a number of answers to or responses to these questions throughout the talks today. So thank you for doing that. If it was accidental, then we're on the same wavelength. If not, thank you for looking at the questions. Okay, so anyway, let me just read the questions. And I guess what I'd sort of like to do, let me just read the questions and then ask if anybody on the panel has a question that they think that they want to respond to, that they think is relevant to or they have something interesting to say about. And then we can sort of discuss that question and then sort of move on from that. We'll see how that goes. So let me just read the questions all first, and then we'll try that route. So what is the relationship between knowledge representation and programming? 2, how far can program optimization get us? i.e. when designing very high level declarative languages, How much can we depend on automatic optimization to address performance issues? Settle clearly had ideas around this. How much do current languages depend on optimization? What's the difference, if any, between smart implementation techniques and an optimization? Do we need a new programming language? If so, how should it differ from current ones? What are the biggest challenges in developing and maintaining large program systems? What's the difference between algorithm design and programming in the large? What capability does your favorite programming language lack that is required for some applications? What will programming look like to a programmer, question mark, if we still have programmers or we still call them that, in 50 years? What is the programming language role in program creation versus program understanding? In the development process, when does specification stop and programming begin? These all have So anyway, so let me just open the floor. I won't pick on anybody, but let you pick on yourself if you have a thought along one of these questions or whatever.
So if I can start, David, I'd say that, we've primarily focused on inductive definitions. I mean, most languages give you capability of defining, providing inductive definitions. But in the real world, you also need non-inductive definitions, in the sense that you have to deal with multiple possible worlds. And so I noticed that Benjamin said well-founded semantics is better than ASP for reasons of efficiency. But there's a fundamental problem that, the real world, in the real world, as humans, we deal with multiple possible worlds. So how do we deal with that? And actually, that's a problem with machine learning as well. So, for example, if I ask the question, do fish talk like humans? Then as humans, we know that there are two possible worlds. One is the cartoon world where fish indeed talk like humans, but in the real world, they don't. So of course, Answer Set Programming has answer to this problem because it supports multiple possible worlds. But for knowledge representation, we do need that capability, and that's something that the mathematical enterprise and the logic enterprise has shunned because we are focused on having a single model. So
okay.
Thoughts on that. So even machine learning system, if we asked, will since they're probabilistic, if there are multiple worlds involved, probably may give the wrong answer or inconsistent answers, because these multiple worlds may have things that are common, but there might be other things that are, inconsistent with each other. And how do you tell which one is which? If you rely on probabilities, then you might end up getting wrong answers.
I guess to me, one of the big differences is that our programming languages are mostly vivid, in the sense that I think Brockman and Levesque used, of saying, we can say things like in a database, this person has a specific name and maybe their address is unknown, but we're limited in the uncertainty that we can express in programming languages. It's like either we know it or we don't. We can't say either A or B or C or E or F. So I guess similar to what Gopal was just saying about being able to represent different worlds. We can't, in programming, we try to eliminate that type of uncertainty and make everything concrete. A variable has a value. And in knowledge representation, we try to embrace that more.
Right.
May I challenge Peter on this point?
Yeah.
The in typical applications of logic programs and Prolog in particular to legal regulations, we often build abstractions on top of vague or open textured concepts. So it's the very concepts which machine learning in particular gives us some kind of grounding for. But that doesn't prevent us in any way whatsoever from building on top of those undefinable predicates, more concrete predicates. So when you suggested that it was difficult to build abstractions on top of concepts or predicates which don't have a concrete, precise definition, I think that that's quite contrary to our experience and quite contrary to the way, for example, the law operates. The law operates typically by having vague concepts like a person has good character or a person has good knowledge of the English language, all of which would feed into more abstract ideas about a person being a good candidate to be a British citizen. And on top of that, you have a hierarchy of rules and exceptions, but building on these soft foundations that require either user input judgments, which make it an interactive process, or provide grounds for an interactive system, hybrid, using machine learning and rule-based, logic-based approaches.
So
Yes, sounds like I need to learn more about that.
so
Okay, Mark raised his hand. Maybe Mark has something to say. You're muted, Mark.
Yeah, I just want to point to a factual error that was made here. So it's assumed somewhere that definitions are about a unique model. In fact, if you remember the example I gave, it had an inductive definition and it had many models. So the inductive definition was a reachability predicate defined in terms of an unknown predicate, or it was actually an unknown function. But if the function on which we define the reachability is unknown, and of course the reachability function itself is unknown. So the reachability definition was an inductive definition, but the object was unknown. And that doesn't match with what was said before. So that's definitely something that we are handling with systems, with logics, with inductive definitions and logics, classical logic. We are handling many domains where there is plenty of uncertainty, plenty of incomplete knowledge, and that is not a problem. So there is a mistake in your reasoning there.
No, I think yeah, what I was actually saying that we need to be able to represent multiple possible worlds and uncertainty and all that stuff.
I agree with that.
Yeah. So,
but inductive definitions is not a problem. It's not blocking that.
Well, I mean, it's if you limit yourself to the least fixed point, then yes, you have a single model, but then you have to basically lift yourself to greatest fixed points and stuff like that to be able to to get the other models.
Not really, because if you have a definition defines something in terms of something else. If the things in terms of which you define a concept are themselves not given or are themselves unknown, then also the defined concept will be unknown.
Okay.
That is how in practice an incomplete knowledge arises in our systems.
Thank you. Interesting. Yes. Ed has his hand up. Maybe Ed has a comment. You're muted.
Right.
There you go.
It's mostly a question to the group and also an apology. It is clear that a discussion of a low-level language such as Ada had no place in this meeting. But nevertheless, there are some issues about programming large systems that I would welcome the opinion of this group. The language in the last few iterations has gone more and more in the direction of programming by contract. That is to say, adding mechanisms that seem to or want to ensure that the program behaves as desired. pre and post conditions on subprograms, type invariants, assertions in the code. And on the one hand, this forces the user to be more explicit about what he intends his program to do. On the other hand, it also helps programming analysis tools, static analysis, theorem provers, and so on and so forth, to prove to some extent that the program will indeed satisfy these assertions at execution time. Is this, in the light of new developments in logic programming, essentially an obsolete and dead-end approach?
Does anybody have a?
No, I mean, I think having that extra meta knowledge is always very useful, and I would say that, you know, we aspire for a world where we just state the axioms for, you know, the stuff that we desire, and then through transformation or partial evaluation or whatever, we are able to actually derive efficient code from there. Absolutely. So for example, given description of a sequential algorithm and given knowledge about concurrency and shared memory, can I derive an efficient concurrent algorithm automatically?
May I add something to that by reference?
I was just going to say, Manuel has something to say about this, I'm sure.
Thank you, David. So the answer is yes. I mean, we have been working in the logic programming community on assertions and contracts. I would say that before contracts were proposed, because it's such a natural thing in logic programming. So we've been forever writing assertions about the programs. The very nice thing in logic programming is that the properties that you put in assertions, instead of being in a different language, in the language of types, they're actually in the language, because it's a logic language, and therefore you can represent relations and properties, you can write it in the same language. And then that gives you a whole unified system where you can state the properties, you can verify them statically for global analysis, for example. And then, because you tend to write properties that are undecidable, so sometimes you will not be able to prove them, then you can use the definitions of the properties as runtime tests, because they are logic programs, so they are also runnable. So your properties, your types, and your sharings, and your pointer aliasing, and everything that you write, and your costs, and your complexities, and so on, are runnable. You can check them at runtime. So you have this whole consistent system of assertions where you can prove statically, dynamically, and so on. Furthermore, because your properties are logic programs, you know, your calling types, your pairs of preconditions, postconditions are logic programs, you can also use them as generators. So the idea of property-based testing, property-based testing generation in logic programming has always been there, even before it was proposed, because by definition, logic properties written as predicates they generate inhabitants. If you write a type as a logic program, then you just have to run the program to generate inhabitants of that type. Furthermore, modern Prolog systems have variable search rules. So you can run breadth first, you can run with iterative deepening, you can, not just depth first like traditional Prolog, you can run with random search rules. So those properties that do your test generation can be run with random search rules, with breadth first search rules, and so on, and you have many parameters to control that. So this whole idea of property-based testing associated with contracts comes completely natural and just follows through. And I shot here, but I could talk for a while about this.
Thanks for the reassurance, but this is exactly what happens currently in Ada, because these assertions, pre and post conditions, are written in the language. It is part of the language now. And indeed, if Spark, which is a sublanguage with a strong proof system, can show that these properties are satisfied, then everything is fine. Otherwise, they do generate runtime checks.
But can you generate tests from them? You see, that's where the logic programming really shines. You write the properties, the assertions, in your language, but then you can use them to generate test cases because they run backwards. They
That's the next step.
create inhabitants. You see, it's even richer. Plus, this has been done since the 90s. So
Thanks.
Thank you. Okay, Tom, I think you're next and with your hand up.
Yeah, so I have a question for Peter. So one of the things that you touched on in describing the history of AI was the most recent period, 2020 to 2022, where you said objectives become critical. You had a slide about prompt engineers, but perhaps there's a need for alignment engineers. And really my question is, what do you see in the way of languages for specifying objectives, and how do you think that is going to play out?
Yeah, I think that's a great question. Certainly alignment is important. And I think one of the reasons we're having problems with all these issues is that we just don't have experience figuring that out. And and I realized I was guilty of that I wrote 3 editions of this textbook that said, we're going to define AI as maximizing expected utility, and you give me a utility function and I'll give you a cool algorithm to optimize it. But I never questioned, well, where did that utility function come from? It's just like, it's assumed it was handed to the engineer or the researcher, and not that it was something that had to be discovered, and that there are all these societal issues of fairness and privacy and everything else that goes into that. And now we're having to deal with that. And, I deal with engineers who say, oh, it was so much easier in the old days. We just launched things so fast. And now there's all these reviews for alignment and privacy and fairness and so on. And, it's such a pain these days. I'm usually able to placate them by saying, well, how many more people do you launch to on the first day? And they say, well, okay, it's 100 times more people and it's only 5 times more work. I guess it's net 20 times easier. But, it's just this idea that there's more societal impact from what we do. And so it's more important to get these things right and get them right the first time. And I don't know. I don't know what a programming language would look like that would help you do that. I don't know if it's really part of the language. I know there certainly are tools to explore data for biases and to subset results and say, this subgroup of users is getting worse results than this other subset. But that's kind of after the fact. That's not sort of building it into the programming language. That's kind of a debugging tool. So I would love to see a programming language that helps you get to the right answer in the first place, but I don't see that.
But based on your experience, you have ideas about what a language should cover? What's the domain of discourse for it?
I guess you want to be able to talk about what matters to you, and that there's sort of multi-attributes that you're trying to optimize, and talk about how those get combined, and talk about the distribution of users and what their results are, right? So it's tricky because, in some sense, some people in your community are talking about proofs of correctness and so on. And sometimes that's the easy thing to do. Because it's either true or it's not. But here, there is no one notion of what truth is. And there's lots of trade-offs of you make one aspect better and you're necessarily going to make another aspect worse. And where is the right way to do that? I don't know if a programming language can tell you that, but at least I want to be able to see where I am on that trade-off scale.
So it's an analysis question, you're saying then?
I think so. Yeah, but maybe there's ways to do that. I think so. It reminds me of another issue. Is one of my hobbies is keeping track of all these outages that large companies have, and what's the net reason. And I think it's a great success to programming language designers that it's very rare that an outage is because of a bug in writing a line of program. It's much more common for it to be, oh, well, there was this DNS entry that got screwed up, and then that got propagated from one data center to the next, and so on. And I think the reason why the bugs are there is because we don't have strong typing for files of DNS entries, right? They're just text files, and then we deal with them and mistakes happen. And when we put our efforts into saying, let's have tools like type checking, they do a good job, but we haven't done that in all these newer areas. And well, I just have to get experience to figure out how that happens.
We have Robert Goldman has his hand up, and we haven't heard another place we haven't heard from. So please. Oops, you're muted.
Yes, yeah.
There you go.
So I think the challenge and the problems that Peter's talking about are that they're at the edge of they're outside the model, right? So you're asking the tool, which in some sense is broken, to fix itself, right? So, you know, it's the combination of populations that you don't know about that's being damaged. It's kind of a requirements problem more than a programming problem, right? Yeah, so I'm not sure. I mean, I've read a lot of calls for proposals that look for a magical solution that somehow takes statistics to fix statistics. And of course, there's things like type errors, which we can find because they're signs of doing something wrong. But, you know, if your experimental design is wrong, the statistics don't fix it. So, I mean, I guess, you know, this mismatch against the outside world kind of reminds me of a sort of a similar annoyance, right? It's 2022 and we still don't have programming languages that have units of measurement in them, right? And that's, you know, that's a case where it's really the meeting the outside world that's the problem.
Go has them, at least for some.
I know there are a couple, but no one uses them in production, as far as I can tell.
Interesting. Okay, interesting. I guess the next one is Paul Theroux. You have a question, thought?
Yeah, I think Mark actually was ahead of me, but I can go very quickly.
Mark already had his turn, unless he wants another one. Then could you could you lower your hand?
All right, let me go in the interest of efficiency right away, because it's a general question to all the panel members and possibly more. We have this gospel of declarativeness, which is justified by, well, it's much easier to say what you want to do than how, and if the programming language does it for you, that's great. So there is an evolution here, because these days is sometimes a little bit shorter and easier to say it in Python than, let's say, in a declarative language, or even worse, a large language model, like let's say ChatGPT, you would ask a very general problem-solving question and you get an answer instantly without any coding. So that's in a way, the disruption here in terms of what declarative means. And because we are so committed to that, and that's our framework for thinking, and I'm curious, what are the opinions of other panel members? I think Bob has the hands on, and maybe he can tell us something about it.
Well, you're inviting me to answer a different question from the one I was wanting to address. So I'm a bit of a dilemma here. If I may, I want to address Peter's point about the different objectives that we try to address with our programs, and in particular, whether or not there exists any programming languages which have a place for that. And I would say, yes, there do exist such languages. The production system language has a place called conflict resolution, which is poorly developed, but nonetheless does address the problem of what to do when multiple goals conflict with one another. And there's a whole field called rationality theory, which logic is totally oblivious to, which in turn is oblivious to logic. So there are two disjoint fields. What does it mean to be logical on the one hand? What does it mean to be rational on the other hand? And these two fields don't talk to one another. But the field of rationality concerns itself with issues such as what shall we do in the given circumstances, especially when multiple goals conflict with one another. And there is a model, there is a computational, there's a cognitive model of human thinking, namely the production system model. And there are programming languages such as the production system model, which is very crude in terms of how it deals with this issue. And then there's LPS, which is inspired by the production system model, and logic programming, both which tries to reconcile rationality with being logical. But nonetheless, it's worth noticing that these worlds are disjoint. I mean, they're disjoint in the same way that STEM is disjoint from humanities. You know, there shouldn't be this idea that there's nothing that connects the sciences, technology, engineering, mathematics with the humanities and the other areas that deal with rational thinking. And I think that that's part of our problem today. We too much focus on differences rather than on commonalities. Okay, now I'm sorry, Paul, if I didn't directly address you, but I was burning to come back to Peter on that. That's it.
Yeah.
From me.
Okay, yeah. It occurs to me, I'm a little confused in the, it sounded like what Peter was talking about was sort of changing, sort of learning more about the requirements, learning more about what your system ought to do, not knowing it quite at the beginning, and as it evolves or as you experiment with it, you learn that it should be doing something slightly different than what it's doing. And so it's more of a learning of, you know, refining the requirements or learning the requirements better or improving the specification. And it sounds like what Bob is talking about is including all of the possibilities in your model and then having your model figure out somehow how to resolve those, you know, this doing it wrong now, I want it to do it right next time, resolving that. So I don't know, is that true, or am I misunderstanding one of your 2 points?
It's up to Peter to say. Peter, what do you say?
I think both parts are important, right? So I think you do learn over time what it is the objectives are supposed to be, and you have an incomplete idea at first, and the objectives may change over time. You have to update according to that. I liked part of what Robert was saying about encoding the law, and particularly this idea that we have part of the law is in written regulations and part of it is in case law. And I think, you know, different aspects are easier to represent in those two representations. Sometimes you can write down, thou shalt do this, and if you don't, there'll be that penalty. And sometimes it's really hard to write that down, but instead it's easy to say, well, in this case, they were innocent, and in this case, they were guilty. And in the future, if you get a tough case, compare it to those and find the one that's closest. And you know, we don't say exactly what closest means, but the judges, that's their skill, is being able to figure that out. And maybe our machine learning systems will end up being like that we'll have some language for communicating the laws to them. And sometimes we'll just say the law doesn't cover everything. What are the closest precedent cases, and try to deal with them.
Interesting. Thank you. Yes. Nengfa. You're muted.
Yeah. By the way, are we still on question number 1?
We're on whichever question you want to pull out.
Oh, well, you have number. I think it's time to proceed to question number 2. No.
Okay, sure.
Well, okay. Let me talk a little
my
bit
guest.
about the question number 2. I have written several compilers actually. Recently, 2 compilers. One compiles PyCat to just like a Warren abstract machine. The second compiler is for compiling high-level constraints to set. So regarding the first compiler, of course, performance is always an issue. But regarding the first compiler, I don't think performance is that essential. Well, we know we had a very, high performance optimizing compilers. For example, Peter Verro was here. He implemented a chorus prologue, which was really, really fast. And also Sixtus had a native compiler, which was abandoned for some reason. So I think performance for logic programming performance is not key to make logic programming popular. So assume SWI is 2 times faster. Would it be able to take over Python? I don't think so. But regarding the second compiler, I mean, compiling high-level constraints to set, this is really important. I think performance is really, really important. At least, okay, it's good to win awards in competitions. That's
So if I can summarize, you're saying that in some cases, optimization, I mean, there's not a need for it particularly. I mean, things are fast enough, but then in other cases, for other kinds of problems, then it becomes critically important.
Yeah, the objective. If the objective is to make logic programming more popular, maybe now performance is not a big issue. I have never heard of complaints from users about the performance.
Yeah, when I wrote this question, I was thinking more, not so much about exactly logic programming, but actually I was thinking more like Seto, very high level abstract where you have to choose the data structure perhaps. So you have to do a lot of analysis to figure out the best way to do things. But anyway, but your point is well taken. I agree with you completely. I mean, Jan Wielemacher, I don't think is on this, but if he is, I hope I won't insult him. SWI is by no means the fastest Prolog system up there. On the other hand, it is the most popular by far. So it's clear that the people who are choosing SWI Prolog are not choosing it for performance. They're choosing it for something else. And I think rationally. So yes, in the Prolog world, I don't think speed is not the problem in the Prolog world. It's not the issue.
Well, I should add that Python is the best example to me in terms of the speed, right? For all these years, people telling Python's 10 times slower than whatever C or however, but people use Python anyway. In fact, a few years ago, when we were crazy hiring data science faculty, I remember we interviewed maybe like 40 or something, total faculty, but maybe 10 were in data science. I talked with everyone at one point. For years, people say, oh, use Python a little slow. But that year, I've asked what language they use. This is the year. Every single person saying they use Python, except one person, actually, he was a PhD student of Shoemaker. But anyway, doing database, that was already in C++. But the one person said, I use Java, except when it's too slow, I use Python. I thought it would be the opposite, right? So, and why? Because the library is in Python. I said, then why do you use Java? Well, because it's popular. I mean, because there's some requirements or something popular. So Python, I thought, was the best example in terms of sort of speed matters or not.
Okay, well, it's 5:30. I said we would see where we were at 5:30. We seem to have, this has been a long day. I think of it, a fascinating day. I've learned a lot and found it just extremely interesting. But so I think unless somebody is burning with another question or another answer, maybe we will tie a bow on it and say thank you to everybody. And I think Annie had a few things you might want to say as a conclusion here.
Oh, I didn't have anything prepared. I take all the blames for the schedule problem. I'm always really bad at that. I'm guilty. So when I schedule my students' presentation, you have to think about it. But all I try to do, I will try to compensate. I said I will create, and people ask questions and then collect questions and answers. And maybe we should do a follow-up on this, and next time we don't have presentations, we just have these discussions. Because I prepare a lot of questions and people prepare great answers. I didn't get to see them. But I heard new questions, actually, new points, including actually Robert Goldman. I really like that, actually, even though I stopped him by saying, hey, go have something. Was really the requirement, the capturing requirement is the hardest, right? And utility is a part of it. Okay. So that's all. I would just want to say it's really everybody's effort, every single person, including people who had to leave. Actually, it was for them now it's like a 3 a.m. or something they sent me. So I hope to really make up my problem with scheduling after this.
I also would just like us all to acknowledge all of the work that Annie has put into this, to pull it
That
all
was
together, to
wonderful.
organize it all, to make it all happen, to bring all of these people, all of you wonderful people here. I thank you, Annie.
Oh, it's
it's
all
amazing.
because you guys,
Thanks,
wonderful work,
thanks to
wonderful
both of
people.
you.
I just had to put it together.
Makes
Okay.
sense.
So I
That's
guess the
great.
biggest thing was now at least everybody knows more what everybody else is doing, and if you have questions, who to ask. Okay, so we can definitely continue this, and we're common interested. We're all interested in programming, right? Automating whatever chores and do the interesting things.
Okay, thank you all.
Yeah, thank
Thank you.
you.
Thank you
Annie
very
and
much.
David. Yeah,
Yeah.
wonderful workshop.
Nice seeing everyone.